Hi, I'm Ed Marzell, President and CEO of Kenexis, and today I would like to give you an introduction and overview to our new tool, our new addition to the Kenexis Instrumented Safeguard Suite called Arbor, which is our fault tree analysis application that is tightly integrated into our existing Vertigo SIS safety lifecycle software. So first off, let's just go ahead and log in to Kenexis Instrumented Safeguard Suite. So I'll just go to kiss.kenexis.com. All right. Okay, so simply log in using the normal means of logging in if you have an account. If you don't have an account, you can feel free to send an email to Kenexis so that we can set you up with a free trial. Okay, once you sign in, you log in to the project manager landing page. Let me just select our Kenexis samples facility, which is where the study will reside, and I'm going to go ahead and create a new study. So Arbor is the new study type that's going to bring up our fault tree analysis. So for a study name, let me just put demonstration in and hit create. And I have created a new Arbor study. So you start at the dashboard page, which gives you a little bit of overview. So you could do things like, project numbers, time units are going to be in hours, project notes, and then even revisions and recommendations that are associated, and then some overall results on the project. Now, with all of the Kenexis applications, there's an action ribbon that allows you to navigate around. What I'm going to want to do is I'm just going to want to click here and go to the fault tree page, which is going to bring up the graphical representation of the fault tree. And I'll build out a little fault tree here. I'm just going to do a quick example of a very basic safety function with a pressure switch, solenoid, and valve. So in order to build the tree, it's really simple. I can add basic events, and I can add gates, and then I can add basic events to those gates. So now I've built my basic structure, and I'm going to start with saying, okay, for event number 1, let me go back into the correct mode and try that again. There we go. So for event number 1, the details, the description, let me just say pressure switch fails on demand. I can make this an initiating event or not, which is not going to be important to SIL verification calculations, but in general purpose it does become important. The calculation mode, I can make it either always true, always false, or I'm in this case going to use an event model. And then I can select the event model, which I will get to shortly. Let me just hit update for now and kind of build out the structure of the tree. So my pressure switch fails on demand. And then I have a gate here where I'm going to say the final element subsystem fails on demand. And I can assign a gate type. In this case, it's going to be an OR gate. And I could put, again, notes in here if I wanted to. Just let me click update there. So now you'll see that I have an OR gate here. And when I go to the top gate, let me just say that it would be the SIF as a whole fails on demand. And I'm going to want that also to be an OR gate. So the way I've set up the logic, the SIF will fail if either the pressure switch fails or the final element subsystem fails. And the final element subsystem will fail if either the solenoid valve fails on demand. And let me just hit update there. Or the valve assembly fails on demand. Okay, so with that, I've kind of just basically set up the general structure of the safety instrument function. Now let me go into the events and do a little bit more detail. So you can see over here on this list view that I have everything is kind of set up. So all of my fault tree pages, all of the events, all of the gates, all of the event models, which right now I have no event models, so that's empty. So what I can do is let me set up event number 1 and create a model. So I need to select a model. I can add a new model, or I can add new from library. So let me add new first, just to kind of show you what a model would look like. And let me just say a custom pressure switch is the title, and custom pressure switch could also be the description. And then you can set 3 different types of models in Arbor. It's either constant, which means a constant failure rate and or constant unavailability, an overt failure, or a covert failure. So those are the 3 different types of models. For safety instrumented functions, when we're calculating probability of failure on demand, you generally use the covert model. And then we could type in a failure rate. So let's say the failure rate of this device is going to be 9e minus 6 per hour. We can enter in a mean time to repair. Let's go 72 hours. Test interval, let's just go once per year, 8760 hours, and insert. And then I hit update. Okay, and now you'll see that that information about the event is loaded here. And the custom pressure switch model has also been loaded. I can now actually even start running calculations. So up in the action ribbon, you see the Run Calculations button. I press that, and it will calculate out as much as it possibly can, which is basically just the probability of failure on that pressure switch. So there's probability of failure is the Q, the unavailability, and also the W, which is going to be the failure frequency. Now, what I did here was I created a custom model. But the beauty of using Arbor as opposed to any other fault tree analysis tool is that you can use that full Kenexis database that's built into Vertigo to populate your fault tree. So in this case, let me create a new model. And I want to create a new model from the library. So when I click that, it's going to pop up the libraries that I have access to. So let's say I want to go into the Kenexis Premium library for sensors, and I want to select, let me see if I can find pressure switch. Okay, so we've got a long list of pressure switches available. Let me just put generic in. Okay, so generic pressure switch in clean service. Then I want to select, well, which failure modes do I want to track for this specific event? So in this case, it's going to be dangerous, undetected, and dangerous detected. Well, dangerous detected would end up being 0 anyway because a pressure switch like this doesn't have diagnostics. But I'm going to carry those in. So now when I click insert, it's going to grab all that failure information out of the library and shove it into the database here. Okay, so now this is a covert failure with a mean time to repair of 72 hours, test interval of 8760, and I hit update. And now I have a new model for pressure switch. So let me go ahead and do the same thing to the other items in the database data. Okay, so I'm going to want to import the data for a generic 3-way solenoid valve, and let's go ahead and say de-energize to trip generic 3-way SOV. And here again, dangerous, undetected, dangerous, detected. Hit insert, and there we go. Select that it's a covert failure model with 72-hour mean time to repair, 8760 on the test interval. Hit update. And update again, and now I have all that data for the solenoid valve. So let me build up my valve assembly the same way. I'm going to want to add a new item from the library, or you'll also note everything that I've already entered in the event models, I can pick that event model. So if you have multiple instances of the same type of instrument, they're already defined. So new from library, again, I'm going to go into the Kenexis Premium Library, final element, and for the instrument, in this case, it is going to be a generic air-actuated ball valve is what I typically want to put in here. Air-actuated gate valve. Let me just air-actuated ball valve generic. There we go. Hit insert. Oh, I have to select the failure mode. So again, lambda DU, lambda DD, the dangerous failure modes, and hit insert. And now it created everything. Covert 72, 8760, and hit update. And boom, I have all the information. If I want to run calculations, I go again to the Run Calculations button on the action ribbon, and everything is calculated out. So my probability of failure on demand for this system is 0.02. And it also calculates the frequencies. This would be the dangerous failure frequency in this case. So we're calculating all those items throughout the fault tree. Now, some other items to note in terms of usability, zooming and shrinking are very easy. You can rearrange how things are laid out in the view itself. You can add, cut, paste, copy, delete individual events or entire sections of the tree itself. So very easy to use, and let's not forget, this is all inside the Kenexis online framework. So everything is in the cloud and available 24/7 to all members of the project team. Now, some other details that you may be interested in for project work. You can go and you can get a table and look at all the gates individually. You can get a table and look at all of the events individually, and another table that gives you all of the models that you've created for events for quantification purposes. We also have a minimal cut set view that's going to allow you to look at all the cut sets that were generated in the fault tree analysis calculation, what their contribution is to the overall PFD. So cut set number 1, which is the pressure switch failing on demand, actually contributes 62% of the unavailability and 62% of the frequency contribution. So that's kind of your bad actor. So a lot of information available on cut sets, and you can show the cut sets from the top gate or any lower gate. So full comprehensive cut set analysis capabilities. And then finally, we have the ability to do exporting and reporting. We can export the overall study into an Arbor file, and we can also create reports. Now, reports are generated essentially as exports to Microsoft Excel files. So if I want to export the cut sets, when I do that, it generates an Excel file that I can then open up, and then you will see the printout of all of the cut sets and all of the attributes of all the cut sets in Excel. Similarly, you can print that information out for gates, events, models, cut sets, recommendations, and revisions. And then if you only want the view of the fault tree itself, when you're in the fault tree view, you can click on the print button and it will create an image, and you can open that image up, and it will show you the image of the fault tree for cutting and pasting into report documentation. So that's kind of a quick overview of this new tool that we're very, very excited about. It's quick, it's easy. It's going to allow streamlined analysis. This is a software tool that was written by safety instrumented system engineers for safety instrumented systems engineers. So it's purpose built to make project work very efficient and allows very tight integration into our Vertigo software. So another feature that I should kind of note here is that in a lot of cases, when you're using a SIL verification software package, sometimes you need to externally model something as a fault tree because it doesn't fit into one of those canned 1 out of 1, 1 out of 2, 2 out of 3 equation types. Well, what you can do is you can build an entire subsystem. So a sensor subsystem, fault tree subsystem here in Arbor. And then when you go into Vertigo, when you define your final element, you can simply say to use the results of the analysis of an Arbor study as the PFD or as the nuisance trip rate for that subsystem. So we have really tight integration and flexibility in terms of reporting for safety instrumented system studies. So I hope you enjoyed this quick overview of our Arbor software. We're really excited about it, and we hope that you'll get the opportunity to get a demonstration license and take a look at the functionality and ease of use of the software for yourself. Thanks again.